And can you show? Yeah.
Good.
Okay. Hello, everybody. This is Nicholas. I'm from Group 1, and I'm working together with Ankur, Sahira, Sim, and Callister. We have chosen the education use case in Sarawak. Next slide, please. And first of all, I would like to present the name of our project, which is called Edulajar. This is a combination of the word education and the word Belajar, which means learn in the Malay language. Well, at the village Kampung Kuap, there is a special rehabilitation program, the program Pemulihan Khas, and students, after we communicated with their teacher, the students have difficulties in recognizing the letters from the alphabet, and they have also some problems in reading and writing in their native language. In order to solve this problem, we are creating a learning game for them. Regarding the stakeholders for this solution, for this use case, it's the parents of the children, the school authorities, and we as a development team. Next slide, please. However, there are some problems that we should take into consideration, and due to the pandemic of COVID-19, there are some regulations and the schools are officially closed. There's also one telecenter in the community where individuals can go and have access on internet or make use of computer facilities. However, due to these regulations, there's a limited number to 5 individuals there. So therefore, the citizens of this village do not have available computers. They don't have internet connections at their home, and the only device that they can have access on, it's the mobile phones of children's parents that they can make use of. Our proposed technology is therefore a mobile game application for the students, which will be tracing the alphabet step by step. There will be also a tutorial and hands-on practice how to make these letters, how to draw them correctly. And we are also planning to make to have a sound pronunciation when the user will be clicking on each letter. The advantages for the user is that the application will be offline and they can make use of it without internet connection. So they can use it anywhere and whatever time they want. The only thing that it will be required, only maybe internet connection just to download it or make some updates. Students can also learn step by step how to write the letters and not to have difficulties in that. And they could also memorize the pronunciation of the alphabets correctly. Next slide, please. Well, regarding the expected barriers, as I have mentioned before, the only thing that they could make use of, the children, it's the smartphones. However, their financial situation is not allowing them to have expensive smartphones, so it will be a low-end hardware. And the internet connection that will be required to download the game. However, in order to deal with these barriers, there will be a smartphone availability, even if they don't have access on the internet. Maybe there is a slow connection on their phones, and they cannot maybe go to the telecenter. We will provide offline APKs for the application, and the application will be lightweight, so it could run on their devices. Concerning the product testing, we are going to make a demo, and we are thinking to launch the game to some individuals only. And once it will be tested, then and we see that the application is working and it's helping the children, then we can make the game available to everybody. Next slide, please. Okay, I have finished. I'm just showing you now how our application looks like. Here, for example, you can see the letter, and there are the steps where the student can follow these steps and draw the letter correctly. Next slide, please. This will be also for small letters. Next slide. And this is also one word. It's kind of having some how to say it, in order to also make it a bit more difficult, they could also do that with words as well. Next slide, please. Thank you for your attention. This is the end of my presentation.
Okay, thank you, Nicolas and colleague. Very nice.
You're welcome.
So let me see if there are questions to group number one. Yeah, one question is, can you please send us the slides by email?
Yeah, sure, we will do that.
Okay, so let me see if there are any questions in the chat. I don't see them.
No, I don't see them.
Okay, then I think we must move to the number two, because we are running out of time. Can I invite number two, group number two?
Hello.
Hello, number two. I don't see someone popping. If not, then I invite group number three. Is group number three there?
Yes, we're here.
Okay. Hi, Raj.
I mean, it's about group number three. So if group number two is there, we can wait.
Yes.
Sorry, I think that we can present too.
Oh, you are number two, Maria?
Yes, just that will present for us.
Okay. Then let's start with number two and then number three. Okay.
Can everyone see the presentation?
Yes.
Yes.
Okay, so hi everyone, we are Math for Kids Pro X 3000. Our group consists of Maria, Carmen, Jaspreet, and Ikram. We would like to present our case study, the plan that we are following, the barriers that we had so far, and the stakeholders involved and the technology used. So the use case takes place in a primary school in Sarawak, Malaysia. The kids' ages range between 7 and 9 years old, and our aim is to improve their mathematics skills. The village has access to internet. There are, for example, telecenters. However, our solution also works offline. Okay, so the stakeholders include the children, whose goals is to improve their math skills, the students, parents who want to support their children, the teachers who teach the children using our app, and the app developers, because our goal is to create and maintain an app that is tailored to the user's need. So this is like our plan. we started off by analyzing the use case and having a brainstorm to come up with ideas. We had an interview with the primary teacher to ask questions and to get to know our use case even better. We documented information, knowledge, and process. We, for example, every time we had a meeting, we made a report about it, so we could like reread it and use it as well later. We came up with a possible solution and created a design for the app. And the last step would be like to test the app actually. So about the technology, it's a mobile phone app and the main languages are Malay and English. And our idea is that the user, so the children start off by taking a test. So this is to assess their skills and to see what points need improvement. Hereafter, they can practice basic math such as addition, subtraction, multiplication, division, and sequences and counting numbers between 0 and 100. So the purpose of the test they take is actually to see what points need more focus, so they will know and they can practice keeping that in mind. And there are different levels, and each of the levels contain exercise. So for example, for addition, there's this level easy, medium, and hard. There are, however, some barriers, which is time. So due to time constraints, we have to come up with a good solution within the given 2 weeks. Costs, which means that the app should be sustainable, not only when we make it, but also afterwards. And the language. So we have designed it in English, but it needs to be translated to the Malay language probably. The online context. So right now, everything we're doing is online, so we don't really have a chance to meet the children and stuff. The access to technology, we had an interview with the teacher and she told us that the parents actually are in possession of a mobile phone. So this wouldn't be much of a problem, but we might have to keep this in mind. Internet, which might sometimes disappear, or they might not have always access to it. Okay, so the last step is testing. So for testing, we had the following in mind. So the students actually use the app for 6 months, which would probably be enough to practice and improve their skills and see whether there is an actual difference. We're here after the students would take a math skills test, which is similar to the one they take when they first start using the app. And based on this, we can have like an evaluation to see whether our math skills actually changed by using our app. Thank you. Do you have any questions?
Thank you. Yes, please. It's very nice presentation. And yeah, I'm looking forward to see the application next week, probably at the final conference. So let me see if there are any in the chat. Are any questions? I don't see them. And then I think we must move because we are a bit late.
And don't forget to send the slides.
Yeah, and please send us the slides by email to me. Then I invite group number 3 to present. And that was...
1 second. Okay. 1 second. Share screen. Can you see my screen?
Yes.
Yeah, so we're group number 3, and we have the use case of monitoring plants. And to start, we are a group of 5. My name is Rachai Petian. It's Elizabeth, Baba, Muhammad, Joseph, and Shadrach. So the reason why we chose this use case is because it's quite an interesting one, and it's actually a more sophisticated problem than it is. We call our technological advancement, or let's say technology, we call it spot cure. which allows us to identify diseases of plants instantly, like on spot. Oh. So currently, so how it works, farmer has to, for example, we chose a specific plant for now. So later on, we can further develop into different plants. But for now, we chose maize, which is an important plant in Ghana. And whenever farmers start looking after the plants and they detect a disease, this is how the cure cycle, or from detection to the cure cycle starts. So a farmer has a maize disease. If there is a disease, then he contacts an extension officer, let's say a local officer, who is responsible of giving cure to the maize. Then an extension officer has to go manually verify that this disease exists in the farm. So the farmer contacts the extension officer gives the time or like a date, contacts back, goes back, checks. If there is, then extension officer contacts to MOFA, Ministry of Food and Agriculture, to give cure for maize, where this cure is given back to the officer and then afterwards to the farmer. So if you can see that this whole cycle takes a really long time, and it actually can take months for this process to complete. And the issue is that the parasites or the disease that these plants have just need 2 weeks to kill the whole a hectare of farm. So the problem here is not only detecting the disease, but also contacting the officer in a fast manner. So what we need to do is to be able to automatically detect it, tell the extension officer that we detected there is a disease, so he would not need to go and manually verify it and automatically give the cure to the farmer. So we want to shorten this process from months to at least a week or two, because again, 2 weeks is everything needed for this disease to kill the plants. As you understand, our stakeholders here is the farmer, the extension officer, MOFA, and us. Now, we did a bit of a questionnaire and asked the local people, for example, what kind of technology they have and standard knowledge, so we can understand how we should develop our project so it would suit them. And as it turns out, from 11 responses, 91%, let's say, had a problem with this disease in the past year. And again, 90% of them also have a mobile phone. But the fascinating thing is that none of them have a smartphone or access to WhatsApp. So they just have a standard phone, not smartphone, just a normal phone that you can do an SMS and a call. And we asked them, if you had accessibility to a smartphone or a phone detection for disease, would you use it? And all of them responded yes. So here comes our solution, the spot cure, and how it would work. So a farmer, as we understood, they don't have access to the smartphones. So what we need to do is we need to check if they have or not. If they don't, they need to get. We could spread one smartphone per community village or centers, because in Ghana, as Elizabeth said, they are sharing and caring people. So we can have one smartphone for 15 people, and after they finish using the smartphone, they can return it back with the photos, and then the community center can upload those images. After uploading the images, we would have this service in MOFA, the Ministry of Foreign Affairs, because that's the closest place that we can have, where we could have our solution of detecting those diseases using AI. So they would send us the image, we would detect if there's a disease or not. If there is no disease, we would reject and say, well, we didn't find a disease or a parasite, so there's no cure. And if we do, then we shorten this process and automatically ask the extension officer to get the cure from MOFA, Minister of Food and Agriculture. And this way, the farmer doesn't have to go to the extension officer. The extension officer doesn't have to go back to the farmer, because all of this is going to be done automatically. And our system is automatically going to detect if there is a disease or not. And this way, extension officer can already ask MOFA, okay, this system detected that there's a disease, please give us cure. And extension officer can provide the cure to the farmer for healing the plants. As you understand, we cut, let's say, 4 to 5 corners, which should shorten the process of going and coming back. Because one of the biggest issues that people encounter in Ghana is that extension officers don't have proper roads. Farmers don't want to pay the money to go and go to the extension officer to get checked up. They just want to pay for the disease or the cure. And all of this can be shortened up by just taking a photo and notifying extension officer. So this whole hustle doesn't need to be here anymore. And this way, this solution can actually help farmers in Ghana, specifically for maize, to detect the disease of a plant in like in days, we can even say. It shouldn't take more than a week. That's our projection, reducing the time from months. Thank you for watching. If you have any questions, I'm listening.
Hey, Rajesh, very nice use case and very useful, I think. I have just one question for now. How's the trust of the system? So the extension officer, the farmers have to trust.
Yeah, exactly. So there are some requirements that we need to make. So for example, that the farmer is not going to take a false image, or he can upload a duplicate image just to get the cure, right? These are the things that we cannot control, but there are things like, for example, MOFA, Minister of Foreign Affairs, endorses such kind of so Ministry of Foreign Affairs endorses such kind of movement and says, okay, we can help you, and then we'll trust you. So if you have our service, if we can have a system that they can check on themselves, and we can say, oh, here's a system, you just need to use it. You don't need to develop anything or update it, let's say this way. And whenever you get a response from the system that it did find a disease, you don't need to go and check, because we already found it. So this whole timing process that it takes to farmer going extension officer, extension officer coming back, checking there's a disease, going back, asking MOFA, and then bringing the cure, it takes months. And this should cut down it to even a week, let's say, because all the process is automatic. You just need to take a photo of the farmer, and that's it.
Sounds very good. Very nice use case, a very nice project idea, and I hope to see it working next week.
Hopefully.
Yes. Then let's stop you with your group, and then I'll ask for group number 4 to step in.
Thank you.
Hi, is my screen visible?
Not yet. Now it is. Now it is. Yeah.
Great. So yeah, I'm from group number 4, and I'm Srinivas, and I'll be introducing to the use case in Ghana, which is based on irrigation, and we call it the autonomous irrigation, and our team name is Farmen. The reason behind the name is we are helping the farmers for the irrigation, and we people are working from a faraway distance. That's how we collaborated the name as Farmen. And going to the next slide, which is the team members. So we have Vignesh, we have Ajibola from Malaysia, and Gideon from Ghana, and myself, Srinivas and Mulay. Vignesh, Mulay, and Srinivas, we are from the Netherlands. So we're basically working on this problem. So Ghana has got long dry seasons, right? And when it comes to rainy seasons, it's only less compared to the summer season. So yeah, need of water for farmers is increasing. So it's kind of, they need to judge a lot. And with the global warming effect as well, it becomes tough for the farmers to get in touch with how much water is needed for the day or for a particular crop or certain crops. So this becomes a problem. And right now, according to our research and study, it says people have apps, and also humans try to control it manually, stop the water flow, or kind of switch on the water flow manually by taking a time. And sometimes this can go forgetful. I mean, people can forget things around this, and that's a water wastage as well, which is the main problem behind this. So tackling this problem is our main goal. And there are also various factors which comes into play while tackling the water wastage management through irrigation. So our stakeholders basically include the farmers, which are the we would consider them as the subject experts and the users as well. So next comes the IoT company who is the source of data and through sensors, and also they're also promoters and marketers for our solution. And apart from that, we have the government and the NGO who are responsible for the funding as well as the resource allocations. And apart from that, we have the developers who are other than the farming people, which is us. And coming on to the farmers plan. Yeah, so this is our plan behind what we'll be doing. So getting into the technical, before getting into the technical stuff, I want to introduce you to the how are we going to plan this out? So basically, we are looking into the indigenous knowledge, which is the real focus of our system. We are looking into the local knowledge, and apart from that, we are looking into the data resource as well from the IoT, and we're looking into the various features of the irrigation factor, which is going to affect us, like the soil type, the crop type, the factors like the season, the humidity, the rain temperature. So these are the few features and the columns we will be looking into for the solution we will be taking it forward. So apart from that, we'll also look into the farmers' resource availability, like the mobile phones, or what kind of mobiles are they going to use, and what kind of systems they are much more feasible with. And also, we are going to look at a specific resource for the region, if there's a proper internet connection, or do they work offline with these kind of systems, or how could this particular solution be built for that region, because considering various factors is really important for us. And also educating the local community on the solution, on the technology, is really important for us to make them evolve with the present generation. And we also have a worst case analysis, worst case scenario. What if this doesn't happen? We could also have a backup system for them. And apart from that, we are focusing on the sustainable development as well, like the solar energy, which could be used instead of the electricity. Yeah, and the proposed technology is obviously based on artificial intelligence and machine learning. So we collect all the data points available, which is available around the irrigation environment, like the humidity, the temperature, the soil type, and the crop type. So from this, we collect various factors and try to build up a solution using the prediction model. So it's going to be based on mobile applications where the farmer or the person involved in the farming business gets a notification about the irrigation timing before they could monitor themselves. So it's also human assistant based mobile application, I would say, because in the starting, I mean, at least for 2-3 months, it needs human assistance for the machine learning, for the AI solution to understand the factors behind how irrigation happens. So that's where the indigenous knowledge comes to play for us. So that's the basic foundation of the solution. And apart from that, what we see from this technology, the uses and the further effects, is that it reduces the consumption of water resources. In a sense, it reduces the water wastage. And apart from that, analyzing multiple factors within a quick time for irrigation. For example, as a human being, it's tough to analyze the temperature, because due to global warming effects, we never know what's going to happen the next day, right? So whereas an AI system could take the intelligence and make sure that, okay, next day it's going to be predicted as rain, today it might be hot as well. So that factor, analyzing quick things within a good computation time, is something responsible for the system. And apart from that, faster production of crops and also manageable production of crops is something really needed. And yeah, it could be feasible for future advancements in farming as well. And it helps in decision making for the farmers rather than focusing on growing the crops and the irrigation. And yeah, the expected problem, what we realized from this, is the cost, which might be one of the factors when it comes to technology. So we try to consider NGO and government for the funding purposes, which is the solution. And apart from that, power supply is one more thing, because power outrage is really happening at the southern Ghana. And getting that into account, we thought of having the solar energy being a part of the solution. And apart from that, we will be educating the farmers with the technology, as explained earlier. So basically based on the training and workshops. And as I told you, that's a failure backup system. So it is not an AI system, but basically based on the expert rule system. Since the universe is really small of the data, so we are going to consider the expert rule system as well. So the testing method is very simple. So we'll be building an architecture of the idea proposed, which will be done within a couple of days or so. And we'll be taking it back to the stakeholders in Ghana, and we'll explain it to them and get a constructive feedback. And based on that, we'll be trying to implement in a small environment over there. Yeah, this is all about it, and I'm happy to take your questions.
Thank you, Srinivas. Very nice presentation. Also very ambitious plan. I hope that you can.
Thank you. Yeah.
Also well thought through.
Yes. So Francis has a number of questions to the other groups as well. Francis, can you ask the questions yourself?
Well, yeah, because of time, I just decided to type them so they could probably look at them. They are more of suggestions than they are really questions. Just things that they should probably note. So I don't know if we have the time to actually ask and answer them here.
Yeah, maybe we're running a bit out of time.
Yeah, so they could just look at them and we can discuss them later.
It's very good, and I think we can also send them some suggestions. Also, I have also a number of suggestions, but we will do that in the chat. That's good.
Yeah. Okay.
Thank you. Then I propose number 5 to present. 5.
Yeah, I think that's us. We don't really have a group number, so I just waited until everybody was done. Share screen. Can you see my screen?
Yes.
Yeah, you can see. Okay. Our project is our project group is very small. We are Celine from Unimas Malaysia and Celine from VU Amsterdam, and we are assisted by Vlad, who is doing his master thesis around this topic. The project that we are doing is related to the text-to-speech use case. Only we are aiming at language recognition. So our project is a little bit broader, I guess, than the other use cases, because our technology can eventually be used in many different settings. Okay, so how will we recognize language and why? The figure at the bottom shows a quick overview of how we will do this. We start with collecting the audio data of people saying the words yes and no. These are also the only words that we focus on during this project. And we will pre-process this data and create melt spectrograms of this. These spectrograms are images, so we can use this to train a neural network that can classify images. Right now we have collected 87 audio samples, and we will use these to train our final model. For the validation of the model, we will create a web interface, and yeah, this system will basically ask simple yes/no questions, and our model has to recognize the right answer. So if the test user says yes, our system also has to recognize yes. The stakeholders of this project are also pretty broad. It's us as the developers, and we want to help the people, and these people are mainly the low literate and illiterate people that are now not able to interact with technology simply because they don't understand it, they cannot read or type something to it. So this the voice-based system will eventually remove the barrier to technology for these people. The problems that we expect to encounter are mainly data collection. That's also why we're doing this project in English and not in a local language, because that wasn't feasible for us because we don't have access to these people right now. And in English, we are sure to have enough data to train the model. And well, lastly, this project improves our current situation simply because the speech recognition does not really exist for languages that for the languages the low resource languages, and most people that are illiterate or low literate, they come from these regions. So if they don't speak English, they don't have access to the voice-based applications. Yeah, that's our main project. That's it.
Okay, thank you, Celine. Very nice
Yeah,
project
thank you.
also, and very good. Even with 2 people, you are managing to do such a good project. Very ambitious also. Are there any questions to Celine? If not, then I invite the next group to present. And that's number 6. And that's the Women Entrepreneurship Group, I think. So
Yeah. Hi. Yes, I will do it I'll be doing the presentation. I'll share my screen right now. If I find the right one. Here we go. Oh, that's not the one. Sorry. Can you see the presentation or not?
Yeah, in a few seconds it will come up. Yes, now I see
Okay.
it.
Okay. So hi everyone. Welcome to our group presentation. We have called our project Dayung Bikuasa, which means women power in Bidayu language, which is a local dialect in Sarawak. We are working on women entrepreneurship in Sarawak, Malaysia, of course. Next slide. This is our team. We have Michelle, Mohammed, Zoe, Tosin, and Wani. We're a very diverse team, and we're working on the project in Sarawak with Madame Wani. And our goal is to make an informative web shop. We want to teach the visitors of the web shop about the Sarawak culture and also finding the beautiful, authentic goods that are created by Miss Winnie. And so the actors are the entrepreneurs who wants to sell their goods, the customers who want to buy goods, and the development team, which is us, and we want to develop the site. So our plan is to transform an old website, because there already is a website for selling these goods, but we also want to use some optimization techniques and some marketing techniques to up the game. So the innovation will lie in search engine optimization and Google indexes. We will also use email marketing and create Google business accounts and social media accounts. I think our barriers for this project will lie in showing the beauty of cultural heritage online, because that's a bit difficult, but we will use videos and a lot of pictures to showcase the products, and there will also be stories accompanied with the product, so that you can see what is actually so you can know the story behind the products. And another barrier will probably be the use of online tools, because it's not always as evident for people to use online tools. But that's why we want to use a website builder that is already quite easy to use. And we will also make some instructional videos where needed. So we will have a small test moment with some friends and family, so they can test the website and check out if they miss anything. And we will also just keep close contact with Madame Winnie, who is our contact person. And that's it. Yeah, we want to thank you. This is also a picture of the product and Madame Winnie. So yeah, if you have any questions, you can ask them now.
Thank you, Zoe. Yeah, also nice. So I'm looking at the chat if there's one question. Yes. Let me see. There's a question from
for group 5.
Francis. That's for group 5. I think the question from Francis also that from group 1. Is there any AI involved in Zoe in your application?
So I think the search engine optimization is an AI application, but the problem is that it's quite technical. And as I explained, I can think it's really easy to translate all the technical details to someone who is mostly focused on making and selling beads, so ceramic goods. So we are trying to find AI solutions that are usable for the people, so easy to use. And we will also, of course, like we are trying to figure out how to use it ourselves and make it easy to use for the people that will actually use it eventually. So yes, but it's simplified.
Yeah, very good. Thank you. Okay, so we still have 5 minutes. So I think we, Francis, we can do your questions.
Please send the slides to
us.
us.
Please send the slides by email to me, because this is not an assignment in Canvas. We just made a midterm report that was not on Canvas. So please send it to me. We will not grade it, but it's good to have this, and we'll put it also on the website. Let me see. I think the questions from Francis, that's same for group 1 and group 2. Is there AI involved in your applications? The 2 edu applications?
Hello, can you hear me?
Yes, yes.
Well, our application is more of a technological solution rather than AI solution. We don't have any specialist in AI in our team. So as we asked also Miss Anna, she also said that it's not always the case. So I think we are not going for it. We won't have an AI solution.
Okay.
At the moment, for sure.
Yeah. No, of course it's not that it's
it can be the case.
required. Yeah. It's more solving a problem is more important. Francis has another question to you. Is there consideration for left-handed children? And the next question is, where would the pronunciation come from for the
yeah, I think they had already sent the answer to that.
Yeah, they did already. Okay. Okay.
Yes. So
okay.
Right, so I believe the language. I just wanted to know if the pronunciations were coming from maybe the online or the West, or from people within Malaysia itself.
Okay.
That's the reason I asked that question.
And that is the case?
Yes, he said 2 members from Malaysia knowing the language, so they will help record the letters.
Okay, that's good.
Yeah,
so, do you still want to ask the questions, Francis, or shall we?
Yes, I think one question to group 3 that wasn't answered is about the internet access, because the issue is that we're sending pictures from the smartphones, and in most of our rural areas, in the very remote rural areas, the internet access is often not good or non-existent. So my question to them was, is there any alternatives they've thought about for sending these the pictures? I can't seem to find them online.
In that case, I think.
Yeah, we can move on. I'll maybe the next session I will just ask them directly.
Yes, that's good. Okay, so well, with this, I think we can end our session. And I thank all the groups for very nice presentations. We are really impressed what you did in so short time. And we think that you did a thorough context analysis, and that's exactly what this course is about. So Thank you very much, and see you Monday, the same time as always. And then Prof. Hans will lecture about the essay. He will tell you about help to structure your essay a bit and give you some tips. Because we have postponed the submission date. It's not today anymore because we were too busy with this presentation. So sorry for the sound behind. Here in a family house, so some people don't know we are in a Zoom session. So it's yeah, almost time. So I thank you all for your very nice contributions, and I hope you liked the awesome presentation by Prof. Tamburini, and I wish you a good weekend.
Yeah, thank you very much. You did a good job, I think, given the brevity of time. And see you Monday, and have a nice weekend.
Have a very nice weekend. Bye-bye. Bye,
Okay.
Francis. Bye, Cha. Bye.
Thank you. Bye-bye.
Other participants, thank you for your participation.